Hello again, Year 12. Here we go for part 2 of momentum and collisions. So, this is a closed system again, which means the forces are contained within the system. So whatever force this thing here applies to this thing here is contained within the system. So the force which this one applies to this train here will be an action force, and this one will react with an equal and opposite reaction force. So the change of momentum on this will be the same as the change of momentum on this, but the opposite direction. So if you look at this one, if you want a visualization, you can think of this as strange times, and some crazy child in England went down to the steam engine centre and nicked one of the steam engines and went for a joyride, and he crashed it into a stationary train because everything's shut down at the moment. So here he is, he's driving along very fast and he crashed. During the collision there was a time period that happened over, and we could give you the average force for that, and we could have the mass of this train and the mass of those trains, and because they stick together afterwards, it means that they are then joined as one object afterwards. So the velocity of this is going to be less than the velocity of this. Why? Because the mass increased of the object. So our next board work bit is going to be working out, if I gave you the mass and velocity of this, what the final velocity of the final train is. Nobody was hurt during this experiment, and I was only pretending and making it up in case anybody's concerned about things. Now, the other point which we can make while we're talking about this is why cars have crumple zones. The formula for change of momentum is force times time. Now, the change of momentum of a vehicle at 100 kilometers an hour will be the same regardless regardless of the amount of time, but we can change the force. So if you looked at rearrange that equation, change of momentum equals force times time, and did force equals change of momentum divided by time, you would find that if you increase the time of a collision, you will massively decrease the force. So the purpose of crumple zones is to increase the time. So if we gave this little train a crumple zone, is a sponge from the soldering iron. So here's my crumple zone on the front of the train. If I change the collision time, I will decrease the force. And if you decrease the force, you then decrease the chance of injury. Now, NCA like asking questions about that. They might talk about how an airbag operates to decrease the force. They might talk about how it is that the front of a vehicle is designed to crumple, which you could consider as absorbing the impact. But what it's really doing is it's increasing the time of the impact, which then decreases the average force. Hence, it doesn't injure you as much. Anyway, so we're going to do some board work now on this premise of my wayward train driving along too fast, ignored the stop sign and crashed into the other train. They stuck together and they carried on down the line a bit until wayward person ran out of coal or whatever it is that they're running their steam engine on. All right, thanks.